This is the story of Fort Stockton. Terrain-triggered supercells. The nearby Davis Mountains and Stockton Plateau provide orographic lift, kicking off and sustaining discrete supercells in otherwise flat semi-arid terrain. Meteorologists note that the Pecos Valley is a favorable corridor for supercell development more often than lower-lying ridges. Mesa-plateau edges foster mesoscale boundaries, convergent zones enhancing vertical vorticity and updraft intensification. Dry land surfaces heat rapidly, contributing to steep lapse rates and supporting strong buoyancy. The terrain also promotes storm splitting and right-moving supercells, which often dominate tornado production in the area. Dryland focus with elevated mix layer. The region often develops a sharp dryline, especially in late spring and early summer, creating strong low-level convergence. Warm, dry air to the west opposes moist Gulf inflow from the east, and instabilities build quickly. The western Pecos Valley often experiences a capping inversion via an elevated mix layer, delaying storms until the dryland shifts or late afternoon increases lift, resulting in explosive, often isolated supercells. Low-level moisture return and Gulf connection. Even though the area is semi-arid, strong southerly low-level jets can pull mid-60s dew points from the Gulf, enough for buoyant parcels along the dry line. Corridor of enhanced shear. SPC Day 2 outlooks frequently highlight a mesoscale corridor through the lower Pecos Valley where wind shear, jet support and instability overlap, often stronger aloft than verified by broad outlooks. On June 2nd, 2023, storm chasers noted, quote, a stronger subtropical jet stream aloft and better upper level support in the southern target near Fort Stockton. May 17th, 2019. Despite likely only a 2% tornado outlook in far west Texas, the broader synoptics featured a negatively tilted trough, northward Gulf moisture, and a dryline driven focus. Fort Stockton saw an EF0 tornado occur east of Fort Stockton at 2143Z to 2155Z, traveling for 2.41 miles with a width of 100 yards, a tall base tornado, 1,500 meters on average, and low precipitation, partly attributed to mid-level dry slot in the thermodynamic profile, contributing to low precipitation and also strong storm relative outflow away from the mesocyclone region, often to the northeast, as the tornado moves southeast. There was a large RFD cut around the occlusion, likely in attribute to the drier S aloft, easily able to wrap around the rear flank. The tornado remained in the open field, however it travelled very little distance. Weak steering flow for supercells to translate in often mean stationary or erratic slow-moving tornadoes. The way to estimate erratic deviant motion via research by Cameron Nixon on hodographs, link in the description to the paper, is to estimate the average wind within the first 500 meters of the atmosphere using the hodograph vectors. The first plot can be the surface wind drawn up to the first point of the hodograph, then another to the 500 meter, then find the middle between the two. We will call this 1. Then using the point of the bunker's right motion, it will provide a certain angle moving at a certain speed i.e. 260 degrees over 15 knots, to find the middle between the bunker's right mover to the point 1. And finally, drawing a line from the surface wind to the newly calculated point is the deviant tornado motion. June 2nd, 2023. A powerful event, strong jet aloft, established dryline, high cape, shear, and SPC enhanced risk covered the region. Radar and spotter data confirmed 2 brief tornadoes northeast of Fort Stockton at 6:29 Z and 1 EF1 6:57 to 7:15 UTC, starting near I-10 Highway 67. NWS notes hail tornadic supercell development near the plateau, tornado genesis just southwest of I-10, followed by EF1 damage. Intense rear flank wind snapped power poles at 118 miles per hour. April 19th, 2025. This day featured a tornadic supercell near Sterling City, Texas. On the 1630 UTC SPC outlook, an enhanced risk over central Texas with a 5 to 9% tornado probability within 25 miles of a given point. The environment was primed. Using the SCU-T hodograph sounding, we observed strong instability, 1400 joules per kilogram mixed layer CAPE, 1000 joules per kilogram being the benchmark for favoured supercellular thunderstorm development, with 2900 max unstable CAPE. Most importantly, 80 joules per kilogram 3 CAPE, that is in the lowest 3 kilometers, exceeding the 50 joules per kilogram benchmark. This is favourable for tornadic stretching and tilting or vorticity along any boundary, as well as mesocyclonic rotation wall cloud. This was paired with 0 to 3 kilometer 7.9 degrees Celsius per kilometer lapse rates, very favourable levels. On the hodograph, the 0 to 3 kilometer vector showed large SRH, upwards of 330 meters squared per second squared, and effective bulk shear at 40 knots, greater than 30 to 35 knots for organised supercell development. This favourable profile was only going to be enhanced by topography of the Pecos Valley to allow for incredible efficiency of tornado genesis, and east with any other supercells. The supercell had transformed from little rotation to a favourable corridor where the tornado formed near Sterling City. It rapidly intensified within a few minutes from broad circulation to a large stovepipe, cone-shaped tornado with evidence of strong rotation largely over open terrain. The circulation became concentrated with evidence of vortices kicked up right in the middle of the tornadic circulation, with lots of dust likely reaching peak intensity during this phase of appearance. Why SPC often misses these events. Outlook models may identify only 2% to 5% tornado risk, or potentially no risk at all, masking the mesoscale corridor triggered by local terrain and dryline placement. These setups are highly localized and transient, resulting in surprise tornadoes when datasets lack resolution on the dryline's eastern march or cap erosion. What are your guys' thoughts? Comment below.